Welcome all physics tutorial class follower. My name is Waktola. In this video we'll be discussing on projectile motion using physical lab or simulation. When we come to the meaning of the physical lab or simulation, especially using software, how we can understand the subject or especially natural science such as physics, mathematics, chemistry, in biology. Under this one, we'll discuss the projectile motion. When we come to the meaning of the projectile motion using simulation or physical lab, starting from the main idea of this one, when we come to define the projectile motion is the motion of an object thrown in the air affected by gravity and air resistances. So using this simulation, how we can understand the subject means that once an object is in motion, it follows a curved passes called a trajectory, thinking of how the basketball acts toward the hoop. Now, why is projectile motion is important? Understanding it is not only helps in sports, but also this is crucial in fields such as engineering, physics, and video game. When we come to this projectile, first we have to know the component initial velocity. This is how fast an object is moving when it is thrown. The faster you throw or launch an object, the farther it will go, the other thing being equal. For example, if we ever launch a paper air planes, from this one, the second component of this projectile motion is the launch of an projection, means launch angle of this is the maximum one is what typically 45 degree, gives the longest distance from the most projectile. The other one, the factor is such as what gravity constant pulls the object projectile down, affecting its passes. As the ball goes up, it slows down until it reaches a peak, then its speed is while falling back down. This change in the speed is creates the beautiful arc we call from the thrown objects. From the given this one, when we come to the projectile motion using the simulation, here is what sample learning goals. Using this simulation, we determine how parameters such as initial height, initial speed, mass, diameters, and altitude affect the trajectory of an object with air and without air resistance. First, we discuss on the trajectory of this projectile using with the air resistances, and in other cases we will see using without what or in the absence of air resistances. The second one is what predicting how varying the initial conditions will affect the projectiles and provided explanations for the prediction, and also estimate where an object will land given its initial condition, and determining the x and y motions of a projectile independent. Also, we investigate the variables that affect such as what the drag forces, and also describe the effect that the drag forces has on the velocity and the acceleration of the projectile objects. And finally, we discuss the projectile motion using a common vocabulary such as launch angle, initial speed, initial height, range, and the time taken. From the given this one, later I will take you into physical lab or simulation parties. This is the software we use to determine the projectile motions when changing the angles of the projections at different angles. Also, we determine the effect of the air resistances on the projections. Once starting from the initial 80 degree, 60 degree, 45 degree, and 30 degree, at what angle this projection or the trajectory is what increase from this projectile to what the launched one. Here is what the height is 0, means the launched place is what 0 meter above the ground, means the object is what launched from the surface of the earth, and the angle of the elevation is what, according to the given this one, we can use what 80 degree. This is what 80 degree, and the speed of this one we can use 18 meter per second or 20 meter per second, and let we see one by one. Starting the first one, when we come to the projections, the height is what 0 meter above the ground, and the angle is what 80 degree, and the other one, the subject or things we thrown is what different, cannonball, custom car, in different is here is what the gravitational field strength is 9.81 meter per second, and the here is what the speed is approximately, let we use what 20 meter per second. Once 20 meter per second. When we launch, look, it is what increase and reach at this point is at angle 80 degree. 80 degree. Look, this is what when we throw a cannonball. Look at 80 degree. Look, this is what the trajectory or distance from the launched place to what the landing. There is what in the absence of what air resistance. According to the given this one, air resistance is what 0. Now let we use the air resistance, means drag coefficient is what 0.47, and when we launch, somewhat the distance from the launching and landing is what decrease. Now let we change the object we throw from the cannon custom. Now look, now when the mass of the object is what increased by a given value, there is what decreasing the trajectory or distance from the launched place to what the landing point. Now let we change the angles of what projection from 80 to 60, and air resistance is what on. Look, when angle from 80 to 60, there is what the trajectory is what increased by a given value. Look, amazing, amazing. This is the impact of the angle on the projectile motion in case of what air resistance. Now let we change the angles of this projection from 60 to what 45 degree, and observe when the object is what launched. Look, amazing, amazing, amazing. You see that there is what increasing the trajectory or the distance the object is what launched from the launching point to what landing. You see, in the presence of what air resistance. Now let we change the angles of the projection from 45 degree to what 30 degree. Once wait. Okay, look, there is what decreasing the distance from the launched point to what landing is what decreased by a given value. In what air resistance is what applied, means drag coefficient is 0.47. The next step, let we change the air resistance is what empty, means without air resistance. Now look, there is what increase the landing is what from the launching to landing is what increased by a given value. Now this is the impact of what air resistance on the projectile motions. Next, I am changing the angles from what for 30 to 45 degree without air resistance. Look, amazing, amazing, amazing. Really, this is amazing, amazing. Look, this is also in the absence of air resistance. in the absence of air resistance, the projectile motion is move long distances from the launching positions. Now, when we change the angles of these projections from 45 to 60 degree without air resistance, we observe where the object is launched. Look, there is decreasing by given value. There is decreasing by given value. This is the impact of the angles of the projection. Now let me change from 60 degree to 80 degree. Look, amazing. Really, this is amazing. Amazing. Now, from the given this simulation, we observed that in the presence of air resistance and without air resistance, at the same angles of the projections, at the same of angle of projections, the distance moved, the projectile object is different from each others. Second, in the absence of air resistance also, in the presence of air resistance also, the trajectory or the distance of the object, launched object to the landing is different. This is the importance of simulation from the given this one. Without going to laboratory, we simply using this software, we can determine the differences in the impacts of the angles of the elevation, air resistances, and different impacts can change the trajectory of a projected motions. From the given this one, as we observe the motions of the object at different angles, there is the trajectory or the distance from the launching to landing is different in the presence of air resistance and without air resistance, also different factors. From the given this one, I hope that you have observed there is a given idea what the impacts of air resistance, what is the impacts of the angle of the projection on the trajectory for projectile motion. Let me ask you one question concerning about this. What is the maximum angle of projection at given choice A? The optimum angle, what is the optimum angles of from what is the optimum or angles of projection for 90 degree, 60 degree, 45 degree, and 30 degree. From the above activity, the maximum or the optimum angles of projection is at 45 degree. At 45 degree, the angles of the elevation is the maximum one. In general, today we're discussing on the simulation. Simulation means on the projectile motion. The projectile motion is the motions of a given object. It is in the air. One object is moving in two dimensions, x and y axis. This from the given this one, there are different impacts on the motions of the object. One is the parameter which can determine the motions of the object is the angles of the projection. One. The second one is the presence of air resistance. The air resistance. From the given this one, we have learned some parameters which can impact on the projectile motion. The first angle. Second is mass of the object. The third one is air resistance. As I try to mention the above or the earlier, this simulation lab is especially for subject physics, mathematics, chemistry, and biology. If you have any subject, any questions, please send your question at my YouTube. We will discuss different questions. Thank you for your attention. Thank you.